Okay, so we're going to look at the distance and gap tools, and what I've got is I've got a block here and I've got distances I need to measure, and we're going to use these tools and just go through how we use them for certain situations. So we've got like the overall width and length and maybe the distance between a couple of circles. So I've got my part loaded on my microview already, and I've just gone ahead and measured a few items, got some lines and some circles. So first thing I'd like to do is I'd like to measure the distance between this circle and this circle. So for that I'm going to select the distance tool, which is this tool here. I simply click on it, my program gets an input called distance, and then I select the elements I need to check the distance between. So in my case it'll be this circle, and it's going to be this circle here. Okay, and then I get a selection of what solution I want to use. So I could measure the distance from the center points of the circle, which is what this middle line is in slightly bolder blue. But I could also measure the smallest distance between the two circles, or I could go to the outside. I'm just going to go ahead and select the 2 points in the middle. Okay, so once I've selected OK for that, what you'll notice is I get a line going from one circle to the next, and my summary tab also displays some information. So here you can see I've got a pitch, X, Y and Z. If I click off my line, you'll notice it becomes dotted. The reason it's dotted is because it helps to differentiate between what a feature is, like this solid line or this solid circle, and then a dotted line you can tell at a glance is a distance measurement. The other tool we're going to talk about is the gap tool. Now people can get confused by each tool and what tool to use in what situation. So you've seen me measure a distance using the distance tool between two circles. If I now try that with the gap tool, just click on that tool, click that circle, click the other circle, you'll see nothing happens. The reason for that is because the gap tool needs 3 inputs, and obviously 2 is not enough to create it. So in this instance, the gap tool is not the correct tool to use. So I'm just going to go ahead and delete that. So we know the gap tool needs 3 inputs. A line, that could be made up of at least 2 points. So I'll click on that one. And then I can go to a circle. And then, because I've got 2 points on my line and 1 point in the circle, I can have a gap. And my gap gives me X and Y as the center location. So that's going to be about here. And then it also tells me the width. It tells me the maximum width and the minimum width. Distance tool can be useful because down here I've got my skew lines. This is the line I've used to align my part. But what distance does, if I'm measuring from this line to this line, it will actually skew this line for me. It will line it up, and then it will come out and say where that one is. So that saves me having to create my skew. And then finally, the information I get here in my summary window for my skew or for my gap, you can configure it. So if we go up to the Tools menu, go down to Configure Summaries and Reports, I can select on my distance, and I can select to show or hide certain features. For example, I could turn off the pitch, and then I wouldn't see that. It's actually the same for the gap. So that's just a quick introduction using the distance tool and the gap tool. Just shows some certain instances and the differences between the 2 tools. Next, we're going to look at 2 commands. We're going to look at the prompts and text commands. So what I've got is I carried on my previous program, and you can see I've got some lines and circles, distances, and I've got some measurements. So what I'm doing now is I'm just going to go back and tidy up my program. So I'm just going to zoom in there. And what I'd like to do is, at the moment this program's got nothing for the operator who's running it. It might be nice to put some extra additional information on there. For example, the program revision, when the program was created, who the author was, just information like that. So for that, I'm going to use this text button here, and I'm going to insert that just after this point. So I'm going to right click, and I'm going to go insert here. And you can see my cursor with a dotted line, that's where it's going to insert the next command. Okay, so I want the text command, and what happens is I get a text box appear where I can type in the information I wish. So for my example, I'm going to put the program revision, REV, and I could say it's A. And if I wanted to, I could date it. There we go. Okay, so that text isn't doing a lot, it's just telling the author or the person running it, and they can see at the top right here, just some information about the program. So when it's created, you know, what the part number is, what the revision's for, program revision, all that sort of thing. So that can be quite useful. The other thing we can do is, this text is currently static. It's not going to change. We can put text in our program or a piece of information which the operator can, enter the value. For example, you might need to track the serial number of the particular part being run at one time. So to do that, we're going to use a prompt command. It's a very similar button. It's the one right next to text, and we're just going to hit prompt. That's what I'm going to do, is put at the end of the program. So the cursor's at the end of the program. I'm going to type in a prompt, and there I can say what is the serial number. Okay, so you can see at the bottom of my program, I've got a prompt, and if I now save that and run that, what will happen is my program will run, and when it gets to the prompts at the end, it's going to ask for a serial number. Okay, and there's my serial number prompt. The operator will put in number 1 or whatever serial number it is, and you can see we get an input of 1. That's now been recorded. Now we can have many of these prompts if we wish, and we can get all sorts of data. So I'm just going to put another one in at the end of the program, and I could put the machine number. So I've now got 2 prompts. And as you noticed when the first time I ran it, it came at the end of the program. Well, ideally we might like to have it at the front of the program, so as soon as the operator clicks play, they're presented with information, they have to type in that information. So to do that, we could have put it at the top of our program, but there is another feature we can do. We can simply highlight them, right click, oops, get that out of the way, and we can go to the prompt command, and we can say prompt at beginning of run. So now what happens when I press run after I saved it? You can see both prompts are now on the same screen. Makes life a little bit easier for the operator. Okay, so that's just a short overview of how we can use prompts and text in a program. Now we're going to move on and look at changing a working plane, and this is a very useful feature. It allows us to check angles down chamfers and things like that we wouldn't normally be able to measure when we're just looking down on the part. So for this example, I've got a part on a machine, and we're just going to be looking at measuring a line on this top face and then a line down this angled face here. That's all we're going to do today. It's just to show you the concept of how it could work. So looking at my screen, just to keep things fairly straightforward, I've just got a few lines which refer to this block, and then at this area here, this is where our angle face is going to start. So just to show that, I'm just going to zoom out a little bit, and I'm going to go to the top face there, and you can see we've got this face down here we're going to measure. So first thing I'm going to do is I'm going to measure that using 2 lines. So that's my line tool I'm going to be using. First thing I'm going to do is zoom in on this top face. I'm going to switch to my actual lighting. And I'm going to try and get it in focus. Okay, not quite seeing it. There we go, that's better. And just to really show this concept, actually, I'm going to use points, just so you can see how it's going to work. So I'm going to start about here, and I'm going to take a point, a focus point, and I'm going to move closer to the edge, take another focus point. So I've got 2 points there which I can use in a minute to construct my line. Okay, and now I'm going to go off this edge onto this angled face. So for that, I'm going to need to change my lighting. So I'm just going to try that lighting. Maybe that one's better. Yeah, that looks a little bit better, so I'll stick with that lighting. And what I'm going to do is take a series of points. So I just take a series of points down the edge. You can see actually it is an edge because the focus is out, and when I put a focus point there, it should be able to find it. So you see this band going across where it's out of focus and in focus. Okay, and then maybe just one more. Okay, good. So what I'm going to do now is I'm going to zoom in on my screen here and make sure you guys can see that. So what I've got is my focus points there. I've just got a few points in a line, and now I'm going to construct a line from that. So to do that, I'm going to say I want a line, and I'm just going to click. There's my first line, and now I'm going to change the view I'm looking at. So to do that, I'm going to use the view buttons, look from the right view, and there we can see I've got my points going down the face. So that's what I'm going to do now. I'm going to create another line, and I'm going to select these points. And you can see what's happening as I select these points. My line doesn't look correct. It's supposed to be going down at a nice angle, but it's still going across like that. So I look from the top view, it's still the same line. So looking from the right side, that isn't correct. Now the reason that isn't correct is because we need to change the working plane. So here's what I'm going to do. I'm going to delete that line, and I'm going to do the same thing, but I'm just going to change the working plane. So I'm going to put a new system in there. I'm going to click the working plane button, which is this one here, and you can see it goes to YZ. So now if I construct my line, I should be able to click, and you can see it joins it up as expected. It's drawing it correctly. And then what I like to do, just so I don't get confused, is recall the previous system, and then I'm back in my XY plane. So now I've got a line down there, I've got a line down there. I could do such things like check the angle, I could get the intersection point. So it's a really useful tool which you can use to check things like chamfers or anything that's not on the XY plane. It can be really useful in many different situations. Now we're going to move on to look at exports, and Inspect gives us the option to export to SPC software, and one such software we've got is ProLink. And I'll just put it on screen. You can see I've got 3 results there, and I've got 4 characteristics. Now what we've done here and what we're going to show you is how we could export data to a software, SPC software like QC Calc, or simply to a text file. But it'll all work the same way, it just exports at the end of the program. And what you can notice here is I've actually got a serial number for each part as well, so we're also able to send non-measurement data to complement the part as well. So that's the goal, and this is how I've achieved it. First of all, we've put tolerances into our features, into our outputs, and we've also set our exports. So to do that, we've just highlighted an item and we press the F4 button. So this brings up the feature exports, and we can simply select on the left-hand side what it is we need to export. So in my case here, I've got a distance and I want to send the X value results to my export. And I've just given it a name, so I've just called it dim1. Okay, I've done the same thing on a few circles. You can see I've just output a diameter. I haven't put a name this time, but it still works. And the way I did that is, instead of clicking them individually, pressing F4, we can either shift click and get a group, and then we can press the F4 button. And then we're able to export the diameter for all of those features at once. So once you've done that and you've created your program, there's two ways of exporting. First one, we can just go to File Export. Now this is it's a one-time export and it's a manual operation. But a better way to do it is, if you've got a batch of parts and you want it to create this export after every single part. So I'm going to close that and I'm going to go to Tools and I'm going to go to Playback Options. Now this gives me the playback options to export after a certain event, and I've simply selected after run. So that means it runs the program, then it'll export it. The next thing is just a file name. So I've currently got an STA file, which is going to go to ProLink, but that could be a text file, could be a CSV file, and then you could open that in other applications. Then we've got some other options, things like run separators, just means we can send a batch of parts. If we measure 12 parts on here, we can still send that. It doesn't have to be after one part. And then we've just got certain delimiters, how we want to separate the part. Do you use a comma, a point, things like that. And then you get a little preview at the bottom of what your file is going to look like. So if I click OK on that, and then I run my part, I ask for the serial number. I'm going to write in Matt this time. And then the program's just going to run and it should export. And then what we'll see is, we'll see in ProLink another dot will appear and we should see the serial number will change. Okay. Okay, so now you can see I've got 4 results, and you can see the last one there, the serial number is Matt, so that's all gone through fine. So that's how you can get to export to a certain SPC software, but also you could just do it export yourself, and I'll just show you how we can get it into a CSV file. So that's where it's going to go. I could also put it to a serial port if you use such devices. You can just configure all the information you need to send it to your serial port, but I'm just going to go to a file. And if I click OK, just replace it, I can then open that file, and it should open in Excel. And now you can see that is my file with those features. Okay, and that concludes some of the export options we can do with the MicroView.